Hello all. Welcome to the SolidWorks Electrical webinar. I'm Shriganda and I'm working as an application engineer here under Beacon. In today's session, we will be looking at the future of electrical design with SolidWorks Electrical. So majorly, I'll be showcasing how harnesses would be working under SolidWorks Electrical, how we can build these circuits in a 2D scenario, how we would represent it in a 3D scenario, how the SolidWorks Electrical will be working, all of that we'll be looking into. So let's start off with a small technical presentation where then we will move on to a product demo and then come back to the technical presentation. So when we're talking about SolidWorks Electrical, so you would have heard about the mechanical CAD. So mechanical CAD design where you will be able to build models, design them, play around with all the features that are provided in mechanical design and so on. So what is SolidWorks Electrical? So we'll be looking at that today. So before we move on to SolidWorks explanation, so I want to just give you an idea of what and all we'll be covering today. Okay, so the agenda would look something like this that you can see on the screen. So we'll be looking at the typical industry scenario where we can, understand what is the scenario right now, and then what is the usage of wire harness, what is the module even presented for in the SolidWorks Electrical, what design challenges we'll be facing as an electrical, industry, why we need to choose SolidWorks Electrical, how will it cater to the design challenges. Then we will look at a detailed product demonstration, and then we will also see what other modules can be covered under SolidWorks Electrical. I have also put together a project plan that I'll be showcasing to you so that you can understand what is the way to go about in this SolidWorks Electrical software. Then we'll move on to the question and answer section, that is towards the end. You can just type in your chat boxes whatever your queries are and we can answer most of them, right? So we'll go ahead with the presentation. So whenever we're talking about a typical industry scenario, right? So in by default in the electrical industry, we have a product-based design always. So this product-based design will always have some market competition, right? So that is the basic one. So obviously there is always going to be a competitor for every product that you produce. But here the product development will be done in a design cycle time, in a specific design cycle time. But what happens is due to some sort of design challenges and all, you will see a higher design cycle time when compared to the others. Now, another thing is project errors. So, mistakes are, usually possible whenever you are working with any kind of design or anything, there is a chance for errors. So in that case, how do we tackle it? How do we work on it so that the product is more focused on and it has, a complete development cycle without much errors. So there is a possibility of having some percentage of errors that is allowed, but after a point, some errors should not be allowed. So these kinds of scenarios, and you can see because of all the above three, whatever I have mentioned, market competition, high design cycle time, project errors, because of all this, low productivity also might be caused, and this low productivity will be directly affecting the product. Now, this is where the entire, portfolio would be in a trouble, you can say. So because this is a product where it needs all of these, whatever is there, to be fixed in order to, enhance the product design or to complete the product development. So this is the typical industry scenario. It is a normal thing that every industry or every company will be facing, either more market competition you'll be facing or high design cycle time, low productivity or project errors. It could be any one of them, it could be all of them, or a combination of a few available right now. So in this scenario, what can we do? So basically, we can go for the scenario, we can tackle it with our design, right? So in our design, so let us say if you're going for harnesses, so what is a harness? What is its purpose? We will try to understand. Then we will talk about the typical industry scenario and come back to that. There is the reason why I have brought up this particular slide here. So, what do we understand when we talk about harnesses? So, harness is basically a bunch of wires. You can see on the screen there are different scenarios where the bunching of wires has been seen, and it is also representing a neater way of bundling all the wires. Now cable ties are present, so some connectors are present. So some connectors have high wire density, so you can see a lot of wires being connected here in the red highlighted wire zone here. So you can see on both sides there are a lot of wires that are being connected, but they are all neatly aligned inside a harness, which is again a part of all of these connections. So harness would just be like a, you can say, like a neater way of representing a bunch of wires, we can say. Okay. So in certain scenarios, you would have to show the wires as it is. In certain scenarios, you would have to go for harness purpose. So in scenarios like this, you need to have a choice for building a harness or for building the wires, or even in case of cabling, you want a option for cabling. So all of these options are provided under SolidWorks Electrical. So that is why we have posted this particular image and the industry scenario design here. So you can see what are the design challenges that are we are facing as a in an electrical scenario. It doesn't matter which type of design. So it could be harness, it could be cabling, it could be wiring. All three of this, you can see manual wire or device numbering will be a problem, because manually you're doing all of this. So there is a chance for ferrule duplications. Again, as a human, you are going to make mistakes, but how well can you, make those mistakes? You can take those mistakes and correct them. How quickly can you do it? How quickly can you identify those errors and do it? So all of that matters. Now, symbols, you can see symbol customization is a huge challenge, because most of the times what happens is you are stuck with a standard symbol itself, and there is no room for editing or any kind of customization. And for this particular software, you need to have any kind of software, you need to have room for design, because basically in the core of your being, you're always electrical designer, so you need to have room for freedom for creating any kind of symbols you want. So that is also something that we have seen as a design challenge. And bill of materials, as you can see, is also something that has been constantly raised by the clientele, where you will be facing issues with the number of bill of materials. So if in my diagram there are 10 components, then in the bill of materials there should be 10. But there are chances where there might be a mismatch of that. And this, all of this, again, it will go for quality. So where it will impact the design cycle time, and it will cost us some money as well, and the time as well. So here we are supposed to tackle both, because as a designer, your focus would be on the project timelines. But as a manager or as someone as a project lead, you will be looking at cutting costs of the project and making sure the timelines are also viable here. So in that case, so what are the different scenarios that we can expect here is, again, another set of challenges that you can see here for electrical harnessing. So you can see harnessing, again, this is coming back to what is harness we have completed already. So now we understand that, okay, these are the many problematic areas under harnessing design. These challenges that you can see, like intelligent schematics. So why is it called as intelligent schematics and not just schematics? Is because we are allowed to do some sort of you can say, like grouping. So this grouping will make it a much more intelligent schematic, because it understands where it belongs. The wire knows which particular branch it should move in. So these kinds of intelligences are provided by the software generally. So right now you can see on the screen error checking, design rules, design reuse. So if you are using a harness repetitively in the project, So in an assembly, you are going to be using it multiple times. So in that case, you cannot waste your time or invest your time into doing the same drawing design again and again. So in that case, design reuse should be an option that should be there. Then parts management. So this is very similar to bill of materials, and reports and documentation also come under the bill of materials itself. So all of this will have like a effect on the project timeline entirely, because all of these are being done in a particular way. So let us say if I'm going with a drawing, then the line diagram, then the parts management by providing, assigning the parts in the design cycle. And then after that, I'm going for the connections. After that, I'm going for the manual connections. And in the end, I will go for the documentation, where this will all be taking a huge chunk of your time in the design scenario. Okay, so automated cable wire harness is a design challenge for a harness industry, because this is not provided by all softwares, right? So digital form boards, manufacturing drawings, these are also some things that are not yet, full-fledged, availability is not available. So that is one of the major challenges in electrical harnesses, so that we can continue on to the design scenario, where we are facing all the electrical challenges we have seen, the harnessing challenges we have seen. Now, how do we tackle with all of this, right? So, with the help of SolidWorks Electrical, what can you tackle? That is the major thing that we want to cover here. Now, when you're talking about SolidWorks Electrical, you can see automated wiring is one of the major things. From left to right, we will move right now. So you can see automated wiring, enhanced symbol library. So we have a dedicated electrical tool sets for the library creations also. And these symbol libraries not only are storing the standards, you can bring in, import some DWG formats as well, and it's a most versatile tool under SolidWorks Electrical, we can say, the library. So where you will be able to create your own from scratch. You can bring in from outside. You can take the existing one in the library. So all these functionalities are there, where you can utilize all the functionalities to, reduce your design cycle time, focus more on the innovation time, right? Harness grouping is something that is possible when 3D is involved. So it is a major thing. And even in schematics, you can expect that harness grouping. You can even find out which harness has the connectors, has the wires that is required. Then we also see manufacturing parts management. So that is where you see bill of materials and the schematics. Both of them have an intelligent link. So if you add a symbol somewhere with a manufacturing part, automatically a bill of material has been added. So something like that is also available. So all this, so you can see again, schematic 3D data synchronization is available, improved design cycle time. So all this, whatever I have discussed till now, it is only possible under SolidWorks Electrical, because this is where you will be having a complete freedom for all the topics that have been discussed till now, as you can see on this screen, right? Now, another thing that I want to showcase here is what is the electrical design procedure under SolidWorks Electrical. First is the schematic. Schematic is the mastermind behind the entire design software. So schematic is where the SQL will be storing the schematic information. Then we can even push it to 3D CAD, and then only it will move to production. Right? So this is how it will be taking the design route, you can say. So schematic is the first thing. Without schematic, there is no other, way of starting off the electrical design, because that's where you design what is the line diagram, schematics. Then you understand how many components are there based on the symbols, and move it into 3D CAD. So 3D CAD is where you will understand, okay, how many electrical components are there, what are the wirings that can be done, and then it will be moved to production. So this is the you can say design cycle that is followed under the SolidWorks Electrical. Now, this is what the workflow would look like. To start this electrical design, we're starting with line diagram, then the schematics, then 2D layout if required, 3D design, and then routing. So this is how it goes on about. It is a very detailed project plan that you can see here. So we're starting off with electrical design. So first things first, line diagram. Again, line diagram is not mandatory, but if it is a part of your design, you can always add it. When I say it is not mandatory, it is not like something that you can skip, you can skip and then you can ignore that part of it. No, it can be used. It can be easier for anyone who's looking at a electrical design. So any layman, if they want to understand, they can take a look at the line diagram to understand better how the connection has been made, right? So 2D layout, or we can say general arrangement drawing. So all of this also is a part of this same SolidWorks electrical module. Okay. So we'll take a look at the product demo and then we'll come back to our presentation again. So in order to just switch to this particular interface of SolidWorks Electrical, I have just launched this software and opened a particular project for this. A very simple connector based design is what I'm going to be showing with the help of batteries. So you will be able to take a look on that. Okay. So now you can see on the left hand side, there is a project that has been opened, electrical bike harness, under which there is a default document book. And this is under the pages panel. Now under the component panel, you can see the same project name, but in this sub, you can see that it is the locations of the components and the list of components that are already present in the project. Now here in the pages panel, we can see all the pages that are represented under this project. So two sections will allow us to get a whole idea of this project. Now let's start off with the first type of page. So there are different types of dedicated pages that are available under SolidWorks Electrical, which will allow you to do the dedicated design under the dedicated page so that you don't have any confusions as to what is being done there. Okay. So this is the welcome page we can call, and you can notice that there is a title block that has been there by default. Now this title block is one of the common ones that you can find under SolidWorks Electrical. And if there is a title block that you're already working with your legacy data, so if it is in DWG format, you can import that as well. Or if you want to create it here, so you can create it as well. So both options are available. We have that flexibility here. The reason why we provide this kind of library flexibility is because we not only want to cater to the standards of SolidWorks SolidWorks Electrical, we also want to cater to the startups who are going for the in-house design, in-house component information, because our you can say electrical industry is ranging from small scale to large scale. Then we have startup to MNC. So these kinds of scenarios are available. So in that scenario, we can understand that a lot of clients will have a lot of requirements. In that case, we have to cater to all of them. So that is why we came up with this full-fledged flexible model of SolidWorks Electrical, where we can do all of that. Okay. Now you can see that there is a second type of page. This is a type of report actually. So in this report, we can understand how many pages are there. So if I've made any changes, if I want to just update it, so I can just go for updation and it will add anything if it has not been added. So like this, we have a lot of information that is available according to this. And not only that, I can also add in extra pages, extra columns. If I want to get rid of, I can get rid of. And all those changes we'll be looking into towards the end of the demo, because I have a section dedicated for reports. Now, another thing that I want to show here is you can see the folder structure that I have created. So you can see line diagram has its own folder, schematics has its own folder, 3D has its own folder, reports has its own folder, and I have created a custom scenario folder just for the example purpose. So all of this will take a look one by one. Now harnessing layout, what is it going to look like? So you can see this is what it is going to look like. So this is just a dummy representation of what is going on in the actual electrical vehicle. So bike harness, you can see. So if I do want that, if I want a more technical one, so that is only with the connectors I want to understand, with the battery connectors. So then I can choose this kind of scenario. Okay, so you can also see that we have a dedicated table for the connectors as well, where we have origin, destination, equipotential, or you call it as a wire. So wire number and the what is the wire length. Right now there is no wire length that is specified, so that is why it is represented as 0. Now, if we are going to understand what is this particular symbol, so you can see it has symbol properties. So you can go and understand better here, because we have a properties where it says it is the J1 component. It even shows its preview. Along with that, some class, location, function, data is there. Along with that, we also have manufacturing parts and circuits. This will allow me to understand, okay, what kind of circuitry is running in this particular component. So this is the major idea that was developed by SolidWorks, where they were able to add this real-time component along with the circuitry and terminals and all of that information. And once you see that information, it is part of the bill of materials. So if I add it here, it is part of the bill of materials. If it is not added here, it is not part of the bill of materials. So basically, what they intelligently have thought of here is, if I add some symbol here, I should be able to add the manufacturing part for representation purpose, right? So to understand which part is there. But when you do that, automatically bill of materials is being updated, so that you don't have to go and manually create any bill of materials. So like that, we have this option. Now you will be wondering how this has been created. So in order to show some example of that, you can see here we have a symbol library where we will be able to access a lot. So you can see buttons and switches like this. We have an entire library of line diagram symbols only that I'm showcasing right now. You can create your own. The images that you see, all of them are completely different here, because each one you can develop it from a real-time scenario, or if you want to use visualize under SolidWorks and develop the part that has been created from scratch and do it, or even a market image also can be embedded. So this image, again, this also you can understand that there is a freelance of information. So anything that is acceptable for your project, it can be embedded in this project, and it can be shown. So once I place these kind of symbols, right? So you can see how I can do a control C, control V also. If I place this, automatically it's taking as J8. Why is it taking as J8? Is because J1, J2 and up to J6 has been added, and somewhere else I have added J7 as well. So automatically the next consecutive number it is taking J8. Why is this? Is because there is a intelligence behind this software, or we can say like it is powering this entire software, that is SQL. So with the help of SQL, we are able to keep a track of the counters of each and every data. So again, if I take a control C and control V of this, but while placing, again it will take as J9. But now if I want to represent it as some other alphabet, so let us say, for example, X, or let us say, for example, Y. Okay, so Y is the first designator in the project, so automatically it will take it as Y1. Now, if I copy this and paste this, so you can see Y2 it will take. So like this, it will smartly take on whatever the data we have provided last, and then provide the solution. Okay, so this is all you can say like a consecutive way. Now, if you don't want a consecutive way, you want a manual procedure. So you even have a manual procedure where you can just type it out, whatever is required. And in automatic, not only do you get to say J like this, you can say like J connector, something like this. So it will take JCon 1, because again, this is the first of its kind in the project. So that time it will take JCon 1, then JCon 2, JCon 3, something like that. So it will move on with the intelligence of the software. So this is how we will be able to understand this scenario. Now, once we have given this is the line diagram aspect where we're just going showing the representation as to how the connectors are being connected. But to understand in a more detailed procedure, so you can see how many connectors are there, their connection points are highlighted in red, and what are the wires connecting to it. Now, earlier on in the wiring line diagram, you would have noticed that there is only one red wire that is being used. That is because only one cable is allowed to connect between the symbols. So when I say we have this symbol connection, so it is just a representation that there is a connection expected, but there is no wire detailing. So to understand this wire detailing, we will have to go to the schematic or the 2D circuitry part. So where we will be able to get a full detailed view. Now here you can see J1 is the component that has been represented. So here also we saw J1, but how do we understand this J1 is equal to this J1 is because they have been provided with the link with the help of a symbol association tool here, which will provide that the information that this J1 is equal to the J1 here, and they're represented by a single component. So to understand that better, you can see here J1 component has a multi-wire symbol here, that is over here, and you can see over here, and you have in the line diagram. So all these places J1 are there. It is just the same component being represented in the multiple ways. That's all. Okay. So now J1 has been represented. You can see here. Apart from that, we can see the wires running. So what are the wires running? You can see the ferruling also that is available here. This ferruling, whatever has been done, it is an automatic procedure. We have that under the wire destination options. So where I will be able to specify whether I want a wire or an equipotential. Equipotential would be something like a phase wiring. If I have RYB, it will take R1, Y1, B1, something like that. But if I want wire numbering, you can go for this wire numbering where you have 1, 2, 3, 4, 5. That is the scenario. And you can also notice that there is a library of a group of wires. You can see by standard they are there. And you can create your own also if required. So we have numbering groups and all that we can add it. So once that has been added, you can see you can select which one you want. So right now, if I select this phase wire, you can see phase wiring also can be done. So you can see like this. And when I'm dropping it down, you can see red is the last dropped one. But if you want an inverse of that, that can also be arranged. And non-ortho, this is also something that could be required. So in that case, you can use all of these design options that are there, which will again save you a bunch of time for you to move on with your rest of the design. Okay. So all of these wires that you can see here, I'm referring to them as real-time wires, not as a line, because these are wires. Because when I see the properties of this particular wire, you can see data like what is a type of conductor it is a control conductor. Line color, what is it? What is the line type? What is the formula to be followed? So we have a counter. So if I place a wire here, then it will take us wire number 1. Next, if I place another wire, it will take us wire number 2. So it is an automatic procedure. It is based on the wire numbering that has been provided based on the formula. This formula is again related to SQL because that is the we can say mastermind behind the software. So that is what we are being used here. Okay. And you can also see under cabling, so diameter, bend radius, section, gauge, color, all of that is there. If you don't give any bend radius, it will try to take the most appropriate real-time one depending on the diameter. But it is always recommended to give some sort of bend radius so that you have an idea as to how to control the bend radius of the wire. And you can also see here, all of these wires are going again to whichever part they want, and based on that, wire numbering has been completed as well. And not only that, I can also understand that in this scenario, so what are the rest of the connections? So that also can be covered here. Now I'm showing a very simple connection that is between a few connectors here. But in case of a larger harness design, so then you will have a larger circuit to deal with, right? Now, till now, what we have seen is only the 2D part where we were able to generate the line diagram, the circuit diagram. We were able to take a look at the symbol library for line diagram symbols. Now let's take a look at the symbol library for the circuit diagram symbols. So you can see motors. So these types of motors are available. Then any types of PLCs, if you want, they're available. Then we have fuses, disconnectors, and apart from that, if I want to take a look at circuit breakers, you know, connectors most importantly in case of the harness design. So like this, many connectors are already embedded in the local installation of SolidWorks Electrical. But if you want to create your own, you can go ahead and create also, and you can also edit the required ones also. Okay. So if I have this, so you can see this is showing as 1, 2, 3, 4, 5, 6. You wanted a seventh one, then you can just copy and edit it and then save it as a different name with the seventh one as required. And you can see here on the right hand side, you see the cross section of the connector. So this cross section is provided by the DWG I have imported from the original one. And this DWG again, if I have generated in the case of SolidWorks also, I can insert it here as a library component. Okay. So these are the main things that are being done. So far we have seen how to do the line diagram schematic, how to bring the wiring, how to, numbering of the wires is basically you'll go to number new wires and click yes. So right now I have already numbered the wires, so you can see that it is ready made for us. And all we have to do right now is move into a 3D scenario, try to see where all the connectors are present and do the wiring for it. So right now 1, 2, 3, 4, 5, 6 connectors are there, and we need to do the wiring for these 6 connectors. So you can see I have this connectors placed here, right? So connectors are placed 1, 2, 3, 4, 5, 6, and there's some manual wiring also that has been created here. But you can see that these are there. Now, if I just take a look at the right now we have this electrical SolidWorks electrical 3D add-in that has been activated in our SolidWorks CAD assembly, and I can see the electrical information. This is only available because I have an electrical 3D module that is activated here as an add-in, and you can see that J1 component has been associated. Now J2 component has been associated. So like this, you can just check for which and all have been associated. Now I don't want J4 to be associated right now. I don't want the wiring to connect to that. So I just want the rest of the others to connect. So right now I don't want that harness. So in order to add this to a harness, I just have to select all of this, right click and say add or remove to harness, and then I can select which one I want, right? So I can select which harness I want, and you can notice that different wires have been selected. So J1, J2, J3, J4, J5, J6. This is the one that I want to add it to. So it has been created already, but if you want to create your own, you can create your own also. So you can notice that all these harnesses that have been created, they're all dummy harnesses. They haven't been added with any of the components yet. So I can go ahead and delete those also, not required as of now. So you can see here, I'm just going to keep it clean and just stick to the first harness only. And I've just added this to a harness. Now grouping has been done. So whenever I select harness 1, it is J1 to J6, all of them are selected. But I have not linked the J4 yet. So only the wiring between J1, J2, J3, J5, J6 is what we are going to see now. So the wiring should typically be occurring from the cylindrical features that you can see here. Why is that? Is because we have generated it in such a way. Now I don't want this object to be seen here. I'm just going to hide all of these objects just so that they're out of the way of the routing. So if you want to understand better on the mechanical part, now mechanical part, you can see this part. If I open it up, so we have this connection points that are provided. So connection points will allow us to understand that, okay, there is a scenario where it is letting us connect to the schematic. So if you can see here, 1, 2, 3, 4, 5, 6 are there. Similarly, 1, 2, 3, 4, 5, 6 are there. And we also have a cable point or a harness point so that the harnessing will happen. So for a harness to occur, there should be a harnessing point. If you don't have a harness, so right now what happens is all this wiring I have grouped it as a harness. But if I go and run the wires, so it will tell me that there are no wires to route, so nothing to route. Again, if I try to route the cables, that will also tell me that there is no cables to be routed because we have not provided any cable or a wire. We have created a wire one, but we have added it as a part of harness. So what I have to do is route a harness. So I can go ahead with the shortest path right now. But sometimes in your case, what happens is you might have to provide a path in which the wire has to follow. So in that case, you can go for define routing path and it will follow that path. Now route harness we will try on this particular scenario, and I'll just say all harnesses, even though there is only one, it will just take that. And right now what the system is doing is it is going and contacting the 2D software. It is trying to identify from which component to which component, what wires are connected, and what are the details on the wires, because it has to virtually represent this connection, right? So you can see here automatically it has fetched some information. It has taken the right kind of information. Then you can see the harnessing that's happening here. And not only that, the wires are moving through. And you can notice that it is not intersecting with this because it's maintaining its own path, right? So there is a particular path that has been provided. So you can see here. So according to that path itself, it is going to take. So 3D sketch has been provided, wires are also have been taken, and I have left J4 out of the connection. So you can see there are no wires coming from the J4. If they did, they would look something like this, whatever you see here, right? So all of this, whatever we are able to generate, this is a very simple connection I'm showing so that you understand better. So there are six connection points. From six, the wires are being generated, and then there is a harness point here. Since we have done harness, so it will go into a harness mode and it will switch into this kind of scenario. And after that has been done, then you can see that all of the wire harness has been completed, and I can just save this. And if I want to take a design, if I want to isolate it and check, so I can isolate it. So you can see this is what it would look like. Please note that J4 is not a part of it. Again, this is a choice because I've left it out of it. So you can also filter out some components if not required for some drawing. There might be chances you would be seeing that. So in that case, you can leave some components out also. And not only that, you can also go for adding more connectors, giving the connections and all that. But once we have done it in 3D, so what we have done is we have mentioned what is J1 component in 3D, what are the wires, so how to do the wire harness routing. So after that has all been completed, next what we'll be doing is we'll be going for the particular reports. So if I want to understand what are the reports like, so bill of materials based on what I would have given, it is taking here like this. And not only that, it can also create this list of wires by line style. You can see some lengths are already provided. Now J4, whatever is related to everything is 0 because we have not given a routing in 3D. So that is why you can see automatic wire lengths have been provided based on what we have done in 3D. Now in 3D, if I leave out one more connector, again you'll see a lot more zeros here, and you'll be able to understand that according to the placement of connectors only, the wire path or wire, the length of the wire has been taken here. So if I place 100 meters away, so then the wire length will be 100 plus something meters, right? So like that. So earlier on I told you wiring list in harness also can be provided. So you can see section gauges there. Again, if you don't want signal, you can skip this particular module out of it. Now, this is all in a window that we're checking. This is a report manager. In that manager, I'm checking all this. But what if I want to associate this and I want to add it to a part of the project? So I have something called as generate drawings where I'll be able to generate all of this. And once it is generated, I can again segregate them into the right kind of a folder where we'll be able to understand. Now, once this report generation has been done, it will give us a summary of which has been done, which has not been done sometimes in certain cases. So all of this we can just drag and drop here, and we can see that here. So bill of materials, if I choose, you can see like this, it will come. List of wires by line style, this is what it would look like. So you can see 2 pages it is showing. Wiring list and harness, so like this. So this is how we will be able to do the design as per our representation. Now, another thing that I want to just cover here is that we have seen how we were able to build a circuit and all of that. But what if in case there is a reusing quality? So earlier on we discussed that there would be a quality where we have to reuse certain circuitry. So in that case, we have something called as macros, where if you have saved the macro somewhere, you can just reuse it. And while pasting it, you can also choose what type of data it is going to have. So I want location to create a new mark. So let us say if this older location was L1, but now here it is L2. So then I have to say create new mark. If I wanted to retain it as L1, I can keep it as keep existing mark. So like that, each location you can go and link it to some other location in the new project. From project to project also, we can move the macros. We can move it from one page to other page, and we can also go for the placement of the same type of macro in the multiple times in the same page. Okay. So now you would be wondering what is different from macros and copy paste, right? So macros, basically whatever I place here, everything will be part of one library, one main library. So essentially you're also creating a circuit library. Okay. Once you create that circuit library, you can reuse it any number of times you want without any hesitation. So if I just want to place it here, I can place it. Now since it is the same project, I'll click on finish. You can see here it has been created. Similarly, if I want to have a panel here, so if I just want to have some frequently used panels of symbols, so I can have it like this. I can do the connections like that. Okay. So these are the ways that you can explore this particular software. Not only are we able to build the entire folder structure and do the schematic design, line diagram designs and all, we can also go for general arrangement drawings, examples, all of that as well. Okay. So in just to go for the understanding of the technical presentation again, so you can see these are the main, you can say like benefits or qualities that we can see under SolidWorks Electrical, which will aid you to go for a better designing scenario, right? So you can see under productivity. So productivity was an issue, automation was an issue, quality documentation was an issue, collaboration was an issue. So with the help of our software, what are the issues being solved is what we are showing here. So essentially we'll be saving a lot of cost and time, which is the main ideology when it comes to a design team. So under productivity, you can see intelligent automatic, single line diagrams, schematic, searchable shared libraries, design rule checks. So we have design rule checks where you can go see what are the errors. So let us say some wires have not been numbered. You can run a test for what wires have not been numbered. You can go and number those wires as well. And automation wise, we have automatic wire and device numbering. So we already saw that J1, J2 automatically took J3 like that, right? And device and wire numbering also automatically we know how we can do it. We do have some sort of Excel automation as well. Maybe in the coming days we can do a webinar on that as well for you to understand better on what can be done under Excel automation. But if you understand it is only related to macros. So if you have frequently used macros, you don't want to draw and recreate and draw and drag and drop. You want to do it in an Excel scenario where you provide all the data beforehand in an Excel and then you want to run it in the software, you can do that as well. Now, quality or documentation, how do you improve with the help of SolidWorks Electrical is bill of materials, wires, harness, everything. Whatever you draw, whatever you give information, that only is being converted to a tabular column as a report automatically. which is the most that a software can do, because the most intelligence here being used is you don't have to manually do it. You don't have to point that this has to be added in the bill of materials. Once you add it as a rating to the symbol in the design, so it will automatically go into reports. Now, electromechanical bill of materials will be provided with, because electrical separately we will get from the 2D software. But when you move into the 3D scenario, we are also moving into a 3D CAD scenario, right? So in that 3D CAD scenario, what happens? We'll be able to understand that, okay, there is mechanical bill of materials, there is electrical bill of materials, both are going to be used, right? Then we saw collaboration, that is integration between 2D and 3D. So we wanted to run the wire for 3D, but we saw that the data is being fetched only from 2D. So there is a bi-directional integration. So if I delete any component in 3D, it will represent in 2D, and if I make any changes in 2D, it will represent in 3D, like that. Okay. And we can also take a, Excel export of the bill of materials as well. You can see here, I'll just go for the the reports where I have a Excel, TXT, and XML formats also. And Excel formats are very quickly brought into the scenario, right? So you can see here, quickly you will be able to generate it. Within a matter of 1 to 2 seconds itself, you are able to generate this. And you can also embed external features or documents into the electrical project as well. So this is the main ideology that you can see here. But you have seen SolidWorks Electrical, why it is being used, what is the scenario and all of that, what is the product scenario, industry scenario, everything we have seen. But what else can be done with SolidWorks Electrical? Because we only tackled harness, what we can do, what can be done. But in case of what else can be done under SolidWorks Electrical, as you can see on the screen, SPM design is one of the major industries that we tackle. So general arrangement, you can see on the right hand side the images of the general arrangement, also panel design also you can see, and PNID and pneumatic hydraulic design in the right bottom corner you can notice, and any kind of 2D drafting if it is required. So you can use it, because this is we have this as an electrical software, we have wires to draw and everything, but we also have lines, we have small tools that will be making this a normal drafting tool as well. Okay, so any kind of simple dummy drafting documents also can be created from this. And basically what we are trying to tell here is that all these kinds of electrical design, you would have to go for different modules for each specialization. But here under SolidWorks Electrical, we are able to completely get all of these modules under one single platform of SolidWorks Electrical, and you don't have to go for any other platform for a different type of design. Even the 3D electrical, whatever you're saying, it is a part of SolidWorks itself. You have a CAD, you can have an electrical add-on, and immediately you can shift the data from 2D to 3D, like how it has been referenced. So that is the part where we want to conclude for the design scenario. Now coming to the SolidWorks electrical project plan, you can see like we discussed earlier. So these are the electrical design procedures that are there, where if you want to go for creation of any project, it should start with the library component creation, design the line diagrams and schematic. Then you have to go for symbol association, manufacturer parts. After which you will be able to go for locations and functions, generate the general arrangement or automated diagrams, generate a SolidWorks assembly. Again, this can be done by either your mechanical team, or you can even download some assemblies and some of the components can be turned into electrical components. Then you can run the wiring. So it depends how versatile you're ready to get with the software. So either downloading or building from scratch, you will be able to do it. And then towards the end of it, you can go for a 3D integration. Then with the electrical, where you will be able to do the component wizard, then you will be able to go for the attachment from the 2D, and then we get our usual automated reports. So using all of this within probably like 9 to 10 steps, you are able to complete the entire project scenario. So any queries, if you have, you can let me know in the chat box. You can just type it out so that we'll be able to discuss and take it forward. But we have a few questions, that is great. So let us try and answer most of them. Now, Mr. Shivanand Swami is asking if automation control panel design can be done on SolidWorks electrical software. Yes, sir. Thank you for that question, because this is also something that is the major, database of clients that we have. That is control panel design. So apart from harnessing, we also have control panel design, PNID design, as showcased, pneumatic and hydraulics as well. So all of this can be done. Majorly, control panel would be the ideal, uh, software. So it will be an ideal software for this kind of design. You also have asked if what is the difference between ePlan and SolidWorks electrical module. So we can say that each software has its own differences, but under SolidWorks Electrical, what happens is you have a completely mechanical outlook and electrical outlook under the same scenario. And it isn't like it is just only focused on electrical, it is only just focused on mechanical, it is a bit of both, right? Mr. Suresh has asked if there is possible to add cavity parts for connector. Yes, sir. So we will be able to add any kind of part as long as it is represented as a symbol. So if it is not represented as a symbol, it cannot be shown as a mechanical part also. It cannot be shown as a electrical part also. Uh, Mr. Push, you can see here, Mr. Sarvanaraj has asked if there is any way to add manufacturing part for wires. If we are going to, the ideology here is, sir, that if any symbol is there, we can add a manufacturing part for it. But if you do want to add part number, that can be added in with the help of wires that are there. So you can add it, but if you want to represent it as a mechanical part to be part of an electrical bomb, then we would have to say that you can't use wires, then you'll have to use diagrams of the wires, and then you can probably assign some manufacturing part for it. Okay, so there is another question from Pushpa Kiran also, where they're asking if we have the single line diagram, can a detailed drawing be generated from this? Automatically, it cannot be generated. So it can only be generated by creating, and the linking on it, when once it has been done, it can be automatically updated on both pages. So if I have a single line diagram with the J1 component, and if I generate another sheet where circuit diagram with J1 component I represent, and if I provide the link between the both J1, then whatever changes made in page 2 will reflect on page 1 and vice versa. Another question from the same person is if we have IO list in that is input output list in Excel, can drawing be created from this? So in case of macros, we can try and achieve this particular requirement, but at least once it should be drawn so that we can take it in a input output Excel format. Yeah, so there is something called as a voltage drop also. So this is only going to be calculated based on the inputs that are provided. So if you give a particular voltage, so and if there is a there is a particular design rule check called voltage drop, so it will find out if there is any voltage drop and list it out for you. That's about it. But the input should be provided from your end, because there is no simulation of sort that is there for electrical circuits here. So it is just purely a design software. But we can give in certain inputs, manipulate them to get our desired outputs also. And another question from the same person is, does the software help in making general arrangement for panel? So yes, so the answer is yes for that, as I have mentioned earlier. So we would have to link it to the same component. So heat generated inside the panel cannot be calculated based on this, because we don't have any input information as such. So without that, we won't be able to work on it. But if you do give some input information, it will only come as a dummy output, not as a simulation. So whatever heat generated, it can be calculated in simulation software, not under the design software. Right? Mr. Saravana Raj has asked if it can be created. You can create field wiring diagram automatically. So we do have a terminal block creation from scratch. So if I have created terminal X1 in one page, X1 1 in one page, X1 2 in one page, X1 3 in another page, I can get an automated drawing of the terminal X1 with all the 1, 2, 3 in the same diagram. It will automate and give us the diagram. But we don't have any you can say like automatic way of generating it. So if we are going for line diagram, if I generate, it will not automatically create schematic. You have to build it and give a link between them. So we do have terminal block design where you can show the entire representation. Any module for electrical substation. So not particularly so right now, sir, but if you do have some queries like any documentation on how it must be, so you can share it across. I think you already have our marketing email ID. You can put across that documentation. You can raise a query asking if this can be possible under SolidWorks Electrical. We can check what is your exact requirement, and based on that, we can tell you what is possible, what is not, so that you can take an informed decision. And here, Mr. Daniel Prabhu is asking if it is possible to import schematics created by other software. So we can import DWG, DXF formats into the software. And if we have any kind of, uh, uh, you know, uh, circuitry that is there. So what happens is when you're bringing it in from another software, it is basically lines. It is not wires. So here under SolidWorks Electrical, it is wires. So wires is where we will be able to give the data. So some sort of reworking has must be done to make sure that it is going to be compatible with our software. But that is about it. And you have asked about the file extension. I have mentioned that it is DWG or DXF formats. And another question would be, can we use one connector to multiple harnesses? So right now we have one per harness scenario, sir, but there is a product development going on in the backend where they're trying to use the same connector in multiple harnesses. So currently we do not have this particular functionality, but with certain workarounds it can be achieved. I think there is a question from Sarana sir itself where you are asking about simulation under SolidWorks Electrical. As of now, not yet available, sir. Maybe hopefully in the coming years we can expect this one module. But right now it is just purely a design software. There is another question, I think the last question for the day and the session, that is from Mr. Varun Kumar. That is, are the manufacturing part numbers created automatically? So we do have a library of manufacturing parts that you can search for using the search tool. We have a filtering tool also that will help you to search that. But what happens is that is going to be searching for the local library data. If in case you're going for something global, so we do have a content portal where you can go and download some of the parts that are not part of our library. If both scenarios are not usable for you, so both the places you're not able to find the exact manufacturing part, then you can create your own from scratch as well. So you have that complete flexibility, which will allow you to create your own manufacturing part as well, along with the circuitry information, all of that. Another question is, let me just brief you on what is the type of modules under SolidWorks. So for the electrical, we have 2D as a separate standalone software. So you can use it independently from the CAD, and you will be able to go for the schematic training for that also. Around 2 days, you will be ready with the knowledge of the schematics. And a 3D, whatever module is there, what was showcased where we were able to do automatic routing. This was an add-in to the 3D CAD software. So if you're already aware of the CAD software, within a day of training, you will be able to hop onto the software for designing, and easily you'll be able to go ahead with the design procedure. But if you're not very sure of the basics of CAD, so even that can be provided. So like an introductory course. So 1 day of mechanical training also, whichever is required for the electrical to work around with. So that also can be created, and then we can go for the next project plan. That is what we'll be going in. So this would bring me to the end of this particular session. So lastly, what I would like to say is you can take a look at the portfolios online in our website. So if you have any queries on any of these, so right now I've answered most of your queries. But if I have, missed something, or if something that you come up with after the webinar, you can always reach out to us. So we'll be available to assist you on any of your queries, and documentation, you can share it. So you can explain to us what you're trying to do in your company. We can try to help, do the same with our software and make it better if possible. So we also have this demo procedure that we can follow, where we will be able to give you even more detailed demo. Right now what I have done is I have given an overview of the software. So you're, even if you want even more detailed ones, so you can have that by contacting to our marketing team. So we can even provide some hands-on trainings as well. So 1 day where you can try to see how the software would work if it is required, and in-house we will be arranging this. So you will also get an idea as to how the software is. If it is easier, you can go for it, and you can take a call. So all of this is possible. You all you have to do is just reach out to us, and we'll be able to assist you. So again, I would like to thank you all for investing time into this webinar and trying to understand what our product does. So if you have any queries, please reach out, and if anything else, again, you can let us. Thank you all. Thank you all for attending the webinar.